Hi, everybody. Good evening. Uh, I guess I'm the last speaker for the day, and a lot of you would have been hearing a lot about different technologies and might be overwhelmed. So uh, I'll keep it simple, but my session is around serverless and how do you build serverless applications on AWS using more of infrastructure as code, uh, more of integration code, and less of your application code. Before I get started, just a quick introduction about me. I'm Zachariah Noel. I am a developer advocate at Freshworks. I am also an AWS serverless hero. I come from a background of serverless architect. That's one reason why I keep talking about serverless. In fact, just a few minutes back, I was talking about serverless with Aditya out there. So I'm also a co-organizer of AWS UG Bangalore. It's a user group from AWS. I write a lot about serverless on my blog, my newsletter, and I do run a podcast called The Zach Show Talking AWS. So for today, we will look into three primary things, which is the present day workflows that we have on serverless, and also with respect to the direct integrations that's possible as a pattern on serverless workloads. And we'll dive deep into the minimal application code that we could have on our serverless workloads. So with a quick raise of hands, how many of you have already used serverless? Okay, have at least heard about serverless? Yeah. Have you used any product that is serverless based? Okay, so a quick fun fact. While you were RSVPing for this meetup on Confib, that's a totally serverless platform built on AWS. So in case if you haven't used serverless, that is one of the products that is using on serverless. So I saw a few hands that were raised when I asked if you have built on serverless. So I quickly talk about the present day scenario where you have a lot of serverless workloads. So it could be things. One example that I called out was Config, like a web or a mobile application, and the backend and the hosting for that web is on serverless. Or it could be certain things where you have certain uh, be it management or be it infrastructure maintenance jobs that are schedule based. And all of these jobs that run could be event driven. They could be serverless as well. You have a lot of IoT applications, be it in terms of you walk into a store, there's a POS system that is cloud and you order from an app, all of these things, like you enter into Starbucks and you order in, right? So all of these could also be serverless. So folks who just raise their hands, anything that you would want to add on to what serverless application that you're building? I saw some hands from here. So you want to say?
Serverless applications as such, but exactly I have not written any serverless. What I know is like we can use AWS Lambda to create a serverless application is what all I know. Like uh, I create Terraform modules or Terraform code, right? So based on the engineers requirement, I have created one Terraform module for the serverless deployments actually across multiple regions of AWS for customers.
So when you say deployments, what kind of deployments? Is it like creating Lambda functions using a database? What's
Yes. So basically, it's just a Python script that they give us or they push into one of the repositories. So what I do is create a Terraform module, which will be used by developers. So basically, they can use that module and give the path to Python script, the repository. So the module particular Python code and creates Lambda functions and then whatever the configuration they are. So basically, the module is designed on top of AWS module that they generic module that you give, and we give the parameters. Basically, the module has the parameters which will be used by developers. So once the module is available, we will be creating the pipelines. We will give a pipeline structure. We use Concur CA as our CA pipeline. So we give pipeline structures. They use the Terraform resources and give the parameters based on their need, and they go ahead and deploy. So basically, they don't really worry about how I'm deploying my AWS Lambda module. All they know is how they can use module and create a serverless application they know, and they don't need to worry how we are deploying it.
Got it. Okay. So you focus more on building the application part of it, and then deployment is separate. Got it. So while one of the example that was mentioned was around deployment and creating functions dynamically based on the deployments, all of it, you could run a lot of ETL jobs as well on serverless. So you could have your ETL pipelines, be it the source from different providers or even the source from AWS. Like if your data is already in, for example, in S3 or Redshift, all of these things, you can define your ETL pipelines on serverless, which is truly serverless in nature. So while I'm talking about serverless, the one fundamental part about serverless is that you focus more on your application, leave the infrastructure and management of those infrastructure to the providers. Correct? So when you're focusing on application code, you tend to write a huge plethora or a monolith kind of an application using application code, right? So when you do that, your Lambda functions, or if you're using containers in serverless ecosystem, it could be Fargate, where your application code is really huge. When you want to actually look into the application, probably your application at segments of it or modules of it would be doing a CRUD operation, or it could be even uh, talking to different AWS services. So when you look at it, it's basically communication with different services and also doing some read write operations on different databases. All these scenarios may not require a uh, huge code. So your application code could be reduced a lot. So, how do you do it? Is what I'll be talking in this session. So, with that brief context in mind, I'll probably during this session I'll refer to different terms like low code, where I'm actually not talking about a tool that does low code. Instead, it's a reference to low application code. Of course, there is a lot of tools that support low code, but I'll be my primary intent of a low code is low application code in your serverless applications. When you actually look at serverless, there are three primary patterns that come into it. It could be different type of workloads, where be it dynamic provisioning of functions, ETL jobs, web mobile backends, or even scheduled events and patch operations that happen. All of these fall into three primary categories of patterns that you see on serverless. It is orchestration, choreography, and direct integrations. Direct integrations is something that I'm going to talk about later in the session. But for the first part of it, let's look at orchestration and choreography. These may sound very English kind of a words, orchestration, choreography, and you may relate it. The first thing that comes in your mind when you talk about orchestration and choreography is probably a band that has been orchestrated or a dance that's been choreographed. Similarly, how these are executed in that dance environment, that's what happens in the serverless environment as well. So you may have different workloads where you have to ensure that the process happens one after the other. You have to control the execution flow, be it as terms like when you have something like a user registration, you have to ensure a lot of steps sequentially. You have to control that flow. So you'll probably be orchestrating it using different AWS services where you can control the flow and the execution, define your workflow so that it's more regulated. When you have a lot of events coming along, your application is event driven. When you have these applications, you need to ensure that, okay, when event A happens, I need my module A to be triggered. Or be it in terms of event B happens, my module B has to be triggered. How do you do it? You have to write rules. You have to define these configurations, telling that, okay, if this event happens, this is the module that has to be triggered. These kind of rules that you define is really what orchestration and choreography is about, because you're writing rules to define, telling that, okay, as and when these events happen, these functions should be executed. When these functions are executed, I want them to be orchestrated in a specific way. So these patterns are more common when you look at serverless workloads in general. And then there is also direct integrations. So I was talking a lot about minimalizing your application code. The reason behind it is on serverless, especially with AWS, what you could do is you could have a lot of services that can talk to each other directly. So, say for example, if you want to do a CRUD operation using an API, you could directly do it from an API endpoint itself. You don't need a glue code. So that's the whole point about direct integrations, where it enables you with the different services point to point integrations. And when you talk about direct integrations, what usually happens is that you're eliminating your Lambda functions. That's your whole chunk of application code that is there. So when you're reducing the number of Lambda functions, you're basically reducing the cold starts it accounts with, because all of us know that Lambda functions has cold starts. That's uh, that's very evident, right? Any of you have built Lambda functions and faced this cold start issue? Quick raise of hands. I see one hand, two hands. So uh, all of this could be eliminated when you're building direct integrations. So, say for example, if your workload is to do a CRUD operation on the database, you could have your API gateway layer talking directly to your database. Of course, there should be some uh, parsing and transposing of your data models. All of it is possible on these services. You don't actually need a glue code, or you don't need an application code that acts as a glue, so that you get the data in one format, you transpose it or parse it into something else and feed it to the other service, right? So to do all of these things, majority of the services, the four services that promotes direct integrations that I'll be talking later on as well, helps you to build that integrations. So all of these are eliminating your Lambda functions and also enabling you to write direct integrations with different services. While you're doing all of these things, cold starts being reduced, and also there is latency, because when you're integrating with multiple services, you know that serverless is scattered around many services being used in an application, right? So you have to do a lot of hop-ins and hop-outs from different services. So say, for example, again with the same API or the CRUD API example, if you want to do a CRUD operation on a database, your API should talk to a Lambda function. Your Lambda function should later on talk to a database, be DynamoDB, Aurora, or anything else. Once it does that, it has to get the data from the database, return the data back to your API. That is when you will ultimately get the response. So you know that there is a middle layer that is involved that can add to latency. Of course, it's very minimal, but it can add latency. Similarly, you have complex applications where you may use different Lambda functions to route to different modules, different layers, all of it, which all accounts to additional latency. So basically, when you're doing direct integrations with different services, you're eliminating that latency. And the fact about being it, is it scalable? Of course, it's scalable because all of the serverless functions or serverless services are scalable. Of course, they have limits. You would have to be mindful of the limits and not abuse them. But to a majority of an extent, it's very scalable. And uh, I've written applications using direct integrations in my previous organization where we had millions of events being passed using direct integration, and it was scalable easily. We didn't have an issue with it. So the scalability aspect of it is also addressed. So why do you need a Lambda function? You could make it Lambda less with more direct integrations and building applications. So the services that promote direct integrations and the patterns of orchestration or choreography are step functions, which is an orchestrator on AWS, event bridge, which helps with choreography of events, helping you as a smart router between different services. It also enables you with a lot of other capabilities. So these are the events that support two different patterns, but these are internal to your applications. It could be internally talking between different services, microservices, whatnot. But if it's an API layer, like I was talking about the CRUD operation, API gateway directly can talk to a DynamoDB table or an RDS server, right? Similarly, there is something called as AppSync, which is a GraphQL offering on AWS, which can also talk directly to different services. So these four services promote you with more direct integrations on the AWS serverless ecospace, helping you to write applications that are scalable with low latency, and of course, eliminating the worry of a cold start. First off, we look at step functions. So I was talking about user registrations. So in a user registration, you could see this is one such example from user registration, a complex workflow where you may have to control the flow between different components, be it even different Lambda functions, be it fetching data from different data sources, talking to external systems, creating the user's identity in your identity pools, whatnot. All of this could be orchestrated using step functions, where step functions could help you to define the workflow using different flow patterns. Like you could have things parallelly running, you could loop through different items, you could even branch between different choices that you make on step functions, while each of those tasks can integrate with 1,000 plus APIs on AWS across almost every service that AWS offers. So every time you see an announcement that's coming out from AWS, there could be step functions that's supporting an additional API action on a specific service. So what essentially it means is that when you look at this, there is a couple of cognito calls, there are a couple of events that have been generated, DynamoDB operations, RDS operations. All of this is using the APIs of these services, and using those APIs, using the same payloads that the API requires, you're building integrations directly off step functions. And to do all of these things, you have to write minimal code, which is basically the integration part of it, to define what your model is, what's the API parameters that it uses, what's the resource, all of that. And to do that, it's readily available on Step Functions Studio. So it has a workflow studio that is offered by Step Functions. It's a visual editor, but it generates a JSON structure called the ASL, Amazon States Language, where the ASL will define what the input is for different states, what's going to be the structure, how are you going to be passing the parameters across different states. So essentially, when you want to move from the parallel state to a conditional branch state, all of this you can define on the ASL using the visual code editor as well. And the fact about it covering a lot of services makes it so easy, makes it so accessible for developers. Like essentially, I moved a huge monolith Lambda to a step function workflow because it was much easier, much cost effective. And also the fact about it reducing cold starts. The fact is, when you're running a huge workload on Lambda function, it could run a huge bill. Of course, you're paying only for what it's executing for. But if it's a monolith and it's running multiple times, there's a cost incurred. But with step functions, if it's a simpler function, if it's a there are different type of workflows, standard and express. Based on it, the pricing also differs, where you're priced for the duration and also based on the different transition of states that happen on step functions. So making it more cost effective option in most cases, and also it helps you to build direct integration, so you don't have to worry about having a glue code meaning just a lambda function that does this job, because you're just getting a a payload, you're transposing it and then passing it along. To do this, you could directly use step functions, and having complex workflows on step functions is so easy and manageable. And in case if you're worried, okay, what happens if I have 1,000 steps or 1,000 different actions that happen in a workflow? Uh, there's going to be a huge mess, right? Because you can see for few actions, it's a flow diagram, and you feel it's so complicated. You can modularly break this, where you could have something as nested step functions, so basically making different modules or different actions a different workflow itself on step function, and this just invokes it. And, yep. Okay. So step functions can integrate with all of the service, almost all of the services. Yes. So I'll show you in the demo where you can do that. But when you talk about step functions and integrations, it can integrate with almost all the services that AWS has. In fact, recently there was a Bedrock that was launched, right? And at reInvent, step functions started support for Bedrock. So even the new services get ads on, but it's over a matter of time that it starts supporting every other action that's available on AWS services. So irrespective of a service being server or serverless, you can invoke it from step functions. So one such thing that I did in the past was invoking an ECS task from step functions. That's also possible. I hope I answered it. Correct. I mean, you can talk with EC2 as well, and all of the services, because uh, step function integrates with over 1,000 odd API actions across 300 services. So yes, it's possible. Maybe a couple of API actions may not be supported, but to an extent, yes. Cool. Uh, Another thing is event bridge. When you're talking about choreography as a pattern, event bridge kicks in, where you have events from different data sources, different AWS services, or even different SaaS products that you can consume using event bridge, where event bridge can define the rules that are needed for your application to continue its execution, making it more reliable in terms of saying, okay, I have an event where I put an object on my S3 bucket and I want to process it over a Lambda function. So you can define it as a rule on event bridge, where you can say, okay, on put object on this specific bucket, invoke the specific Lambda function. So you will have all the details from S3 to your Lambda function available, making sure that, okay, you may have to run some compliance uh, workflow or anything such, you could do it. Or maybe as simple as you may want to, uh, when you have S3 as an storage for multimedia or photos, and you want to reduce the resolution of it, you can invoke a Lambda function whenever the image is being uploaded to S3, and the rest of it can be taken care of on a Lambda function. So all of those definition as such is possible using Event Bridge and Event Bridge's Event Bus, where you're using bus as a medium for transposing different kind of events to different destinations on AWS. And when you're talking about buses, it's not limited to AWS alone. You can have different SaaS products as well that integrates well. So, say for example, uh, when you have events from GitHub or Freshworks, for example, where you have different events on Freshworks products, they can trigger events on your event bridge in your specific AWS account, making it more easier for you to consume these events. So, say for example, if you want to use GitHub events in your applications or Stripe events in your application, you may have to write webhooks. You may have to use webhooks to trigger those compute section of your application to get all of those data from Stripe or any other SaaS product. With Event Bridge, you can just define these integrations on your Stripe, and you can specify which AWS account, and you can process all of them very easily. Because as and when there's an event on Stripe, this gets triggered. And also with respect to Event Bridge, there's something called as pipes, where when you want to do point-to-point integrations on AWS, be it things like you want to work with uh, the events that happen on your DynamoDB. So DynamoDB has something called as streams. And using those streams, you can define events where whenever there's a create or a put or an update that's happening on DynamoDB, these streams will have events for that DynamoDB payloads. You can consume them using EventBridge pipes. You can process on them. You can filter things on them. And also, if you would want to enhance certain things, you can invoke different components, be it a Lambda function, be it a step function, be it a ECS task, or anything such can be invoked using EventBridge pipe, and it can be the event could be delivered to a specific destination, making the point-to-point integration across different AWS services much easier and more maintainable for developers, where you don't have to write a huge chunk of your application code. When you're talking about all of these things, you may have use cases where you have to run different cron jobs. So Event Bridge also supports cron jobs, where you can have different cron jobs that are defined in your application. So you can define them as cron jobs on Event Bridge scheduler. Based on the time and date and time, it triggers these events. So say for example, if you have to run a monthly billing cycle, so you can define, okay, every month on the first at 2 a.m., for example, you will generate an event, or it'll trigger an event that can trigger a Lambda function or any such AWS service for it to work with, making it more robust in nature, especially when you have a lot of cron jobs to work with. That said about, yes, uh, Event Bridge does not support something like a mesh, but no, it doesn't support something like a mesh as, I mean, equivalent of service mesh is what you're. So there is something called as Amazon MQ, which is again a messaging queue that's available. That's similar to what a mesh is, but not exactly a mesh, but similar to it. So event bus is basically that medium which where the events flow in, and there are different rules that are defined. So these rules will tell you what is the source of the event and what should be the destination for that event. So it'll execute these rules and transpose the events to a right target or the destination. When you're working a lot of these were with uh, orchestration and choreography. But when you have external events or external communication that has to be done to your application via an API gateway, most of the times we think of API gateways as okay, I have an API, I'll invoke an API endpoint and it triggers a Lambda function. That's the common notion. But also, you can have something called as VTL integrations on AWS, which can trigger a lot of things where it can directly talk with DynamoDB, RDS, and things like that, making it more easier for you if it's just a simple CRUD operation. Why invoke a Lambda function, right? Making it a Lambda-less workload so that your API gateway itself can talk to the specific data source. And to do that, and not just data source, but it also supports different things like Kinesis, where if you have to be consumed and it has to be posted on a Kinesis stream, you could do it by defining a API endpoint. And all of these uses something called as VTLs, that's Velocity Template Language on AWS, which is a Java-based language. So you can define all of this integrations as VTL codes, and voila, all your API invocations are going to a specific destination. Another thing that I was talking about was AppSync. So any of you have used uh, GraphQL APIs or anything such? Okay, you may be thinking, okay, I have my GraphQL, I have the schema that's there, and I may want to trigger different applications, so different modules of your application. So how do you do it? Basically, you have to write resolvers for your schema, be it the queries or the mutations or the subscriptions, which in turn talks to different data sources or your compute layer. When you want to do all of these things, again, AppSync, which is a managed and serverless offering of GraphQL on AWS, it allows you to define different integration using two different runtimes. One is a VTL and another is a JavaScript. So you can define your integration in JavaScript to different services, making the direct integrations from sync to that specific data point. So it not only supports different AWS services, but also you could have different HTTP endpoints directly that can be invoked from your AppSync mutation scheme, mutations or queries or subscriptions. So when you have your schema that's ready and it has to talk to different data sources, say for example, DynamoDB or different HTTP endpoints, you can just define the resolvers in VTL or JavaScript to write that integration bit for your schema operations to your data sources. So today I'll be demoing a simple application, that simple workload that I built on serverless. So I'm a Marvel fan. Any Marvel fans in the house? Okay, awesome. So you may recognize this screenshot from one of the Marvel movies where uh, uh, most of them were part of the blip, and they were not existing. So the folks who survived the blip ran different workloads and different things where Jarvis was telling these are the people that went missing. So when it did that, one thing that caught my eye in this screenshot was every person, there was a photo and there was a name that Jarvis could detect. So I thought, okay, fine, let me run this fun project on uh, using serverless, where I have different events that are generated from my S3 bucket. Say, for example, with whenever I upload an image, I use the image, use different services like uh, Amazon recognition, where it can recognize different celebrities. And based on the celebrity that recognition recognizes, I can detect, okay, this person is XYZ, right? Just like in this, there is Scott Lang, that was his name in the movie. So that's the name that's been there. So how do I do this? Whenever I have an image, you can use the QR code to scan. There's a complete blog. There's a GitHub repository which you can deploy on your own AWS account using SAM CLI. But yeah, you can look into the QR code as well. So what this whole workload is that I'm not using a single Lambda function in this. Instead, what I'm doing is whenever I have an image and it is uploaded to S3, S3 generates something called as put object events. So whenever this event is detected, I have an event bridge bus that's available that's listening to a specific S3 bucket and the put object event. Whenever that happens, it kickstarts an execution of a step function workflow. In the step function workflow, what I'm doing is I'm invoking the direct integration with Amazon Recognition, which is an AI/ML service from AWS to recognize different images that are there. I'm using the Recognize Celebrities API, which is trained on a model of all the celebrities out there. So it recognizes the celebrities in the image, and in the response, I get an array of celebrities if there are multiple, or one object if it's only one person. And using the flow of map, what I'm doing is I'm looping through each of those objects, putting them into a DynamoDB table. It's that simple. So whenever there's an S3 event that happens, step function gets triggered, and that will in turn talk with Amazon recognition, get the celebrity name, store it in DynamoDB table. So what I'll do now is I'll just go to my S3 bucket. I'll upload an image. So I'll just take Deadpool and Wolverine. And there is the event bridge bus that's been defined. So you were asking about what an event bridge is, right? So this is how you can define the rule that's there. And you can define, okay, this is the source is going to be an S3 bucket and also the bucket name. And when that event happens, it has to go to the specific step function as a target. So that would have got executed. See the latest execution on my step function. When I go there, there is the step function that's been successfully executed. So I have all the event details from S3 that I get. So the name of the bucket, the details of the object that's been uploaded, all of it. And the next thing that it does is it invokes Amazon Recognition's Recognize Celebrity API, sending the same S3 details because Amazon Recognition uses API where it can take an input from S3 object, S3 bucket itself as an object. So I'm using that as an integration. And it generates an output where there are different celebrities. It detects a lot of other parameters in terms of what are the uh, what are the different characteristics of that photo and that celebrity, and also says it's Hugh Jackman, that's Wolverine in that image. And along with it, Deadpool is not recognized probably because Amazon recognition is not trained with Deadpool's image. Once that is done, it processes each of the recognized celebrity and puts them into a DynamoDB table. You can see that Hugh Jackman with the IMDb's link of Hugh Jackman's profile is being stored on DynamoDB table. this has been stored on DynamoDB as well. So when I ran this workload, all the only action that I had to do is upload an image to S3, and even not even use a single Lambda function, I could trigger a workflow on step functions using the different uh, events that are there from EventBridge, and also with step functions integrating with Amazon recognition, recognize the celebrity, get them, store them on a DynamoDB table. So it is this simple when you think of integration. This could have been a workload that uses Lambda function as well, where I had to write an application code using AWS SDK, write a lot of code, make those API calls, get them, wait until I get that response, do all of these things, which is a hassle or a time consuming thing as a developer. But this is just as simple as going to my workflow studio and defining them. So, to answer your point about uh, how do I how do I integrate with different services on step functions? Step function, if you go to the step function workflow studio, there is a whole list of AWS services. And this is a very long list. So it supports all of these services using different API actions, irrespective of the service being serverless or a serverful service. You can define your step functions to test them out as well. Step functions has this workflow studio where you can locally invoke those individual tasks to ensure that they are working fine or not. So, so in case if you want to read more about this workload, there's a blog that's available. You can just scan the QR code, and the whole blog is available. There's a repository as well where you can deploy the same thing using SAM CLI on your own AWS account. So when you're working with a step function or a state machine that it's called, what you'll have to do is you will have to use different direct integrations where you can use different intrinsic functions that step functions use supports. So here what I'm doing is to generate different UUIDs. There's a intrinsic function. Whenever I want to format things, there's an intrinsic function. Whenever I want to get an element from an array, there's an intrinsic function. All of this is basically different functions that step function supports. So I had to write just this part for when I'm inputting or when I'm storing all of these data into my DynamoDB table. So I was talking about Amazon Recognition API earlier, where I was using S3 object. So events from EventBridge is sent to my step function. From step function, I'm just defining the API parameters, which bucket, what's the object name, and that's it. So yeah. When you think of all of this workflow, this is also available on the GitHub repository that was there in the QR code. But when you go deep into it, there is a SAM template, which is basically a YAML template that that defines different resources on your AWS account. So it could be as simple as what's my S3 bucket, what's my S3 bucket, what's my IAM policy, what's my state machine, the event bridge rule that I was talking about. All of this is defined as infrastructure as code on my SAM template. And when I do SAM deploy, it uses this definition and deploys it to my AWS account. And as simple as you were mentioning when you were defining different resources on Terraform as modules. Similarly, SAM uses the SAM template where I can define different resources and deploy it. This is another example of DynamoDB snippet from my infrastructure and also the state machine that was generated. So when I talk about step functions and you saw the visual workflow from the workflow studio, this is the complete JSON as ASL that's there on step function. You could just generate the JSON file, use it in your infrastructure as code, and deploy it. So, with that and the demo, I wrap up my session about how you can build infrastructure code and less of application code on AWS serverless, using direct integrations and different patterns on serverless, using orchestration and choreography. As Werner Vogels always says, no one size t-shirt fits all, right? So for this workload, this was an ideal approach that I took. But maybe for some other approach, you may need a Lambda function and you may still have to deploy a Lambda function. So yes, that's possible. With that, thank you.